Hello everyone, today we will continue explaining lesson 3.1 about measurements. The part today is about significant figures. Now what I mean by significant figures, from its name, it's like significant or something that has a value. Now when we calculate in science, especially when we have a certain device that I want to calculate or I want to use it in order to figure out a certain number or a certain value, each device that we have in the lab or even in general science, it has a certain accuracy. It can show you a certain number with certain digits, like the scale in our home. For example, scales in our home, they show you, for example, your weight will be 59.2, for example. This is the number that's shown. It cannot show you more than this. It cannot show you, for example, 59.21356 and so on. Why? Because this is the value of accuracy that we need. We don't need more than an integer with a decimal. But when we are talking about the labs, especially with very quantum numbers or the numbers that they are very small, I should be accurate. So with any number that I got, I should care about what is the value of this number and what is the accuracy in this number. So if, for example, in science, if I'm talking about the word 30, in math 30 is 30, it's a number. But in science, 30 is different from 30.0 and it's different from 30.00. Why? Because here the last digit, the digit on the least one will be the last one on the right will be the one that I will consider it as the less accurate number. So here the 0 is the less accurate, so I might have mistakes with the 0. In here we have this 0, which is the decimal, so this one will be accurate and this one is less, and here the last one. So once I add more digits, it means I will be more accurate. So as I said, the number with the least value affect the accuracy of calculations. So 30.0 is less accurate than 30.00. That's why they put a certain thing that deals with significant figures in science in general. Now, how we deal with significant figures or how to calculate the significant figures, there are many rules that we should follow. The first rule, it states that every number is significant except for the 0. Every number is significant. Any number, we should say that this number has a value, except for the 0. When we can say that the 0 is significant and when we can say that the 0 is not significant. The 0 is not significant if it's on the left. So here I have numbers. On the left I have zeros, so these zeros are not significant. They will not affect anything. There is no advantage of calculating them as significant numbers because they will not do anything with accuracy. While when we are talking about the right, any 0 on the right side or any 0 in between, it's significant and we should calculate it. The one on the in between, it will add a value, and the one to the right, it will affect the accuracy, even if it's like a decimal. So for example, if we have this example, 0.3420, so this one, we will not calculate it, and then I will calculate 1, 2, 3, 4. The 0 right to the decimal is considerable. We should count it. Now, if I want to transfer the significant figure into a scientific notation, if it's like a significant figure without rounding, I should write it the same. So here I have 4, I should write it with 4. I should add the 0. I can't write 3.24. This is not correct. I should add the 0. 3.42 or 240. Okay, next I have here 0.004215. So the first zeros, they are not countable, so I will count 1, 2, 3, 4. So I have here 4 and I should write it as a scientific notation like 4 numbers. 300 here, how many zeros to the right? I have 2 zeros to the right, so there are 3 significant figures. So when I write them down, they should be 3.00 times 10 to the power 2. I should not write like this. Here it means I have only one significant figure, and here the accuracy will be less. So once I look at this, I will understand that this machine that you use can gives you an accuracy of 2 digits after the decimal. Okay, the last rule about the significant figures is that sometimes the significant figures are infinity or they are unlimited. When we can say that the significant figures are unlimited or they are infinity, when we count things, like for example 5 apples. 10 students, 2 pencils. When I count, why when I count I can say this one is not a limited significant figures? Because it depends on the situation. For example, I'm in class A has 10, class B has 12, and so on. So here when I'm talking about these counts things or countable things, I'm talking about something that's not accurate. It depends on who are in this class. One of the students might leave, one of the pencils might be broken, and so on. So when I count things, I can say that I have limited amounts of significant figures. The same thing for converting units. Like for example, if I say 60 seconds has 1 minute, or have 1 minute, here I have unlimited significant figures. Why? Because when we want to convert, we have more than one correlation to convert. I can use this correlation or I can use other correlations. Like for example, I can use that 1 minute or 60 minutes is 1 hour. I can use this one, and so on. So once I have more than one correlation or one way to determine the change or how to convert one unit to another, here I'm talking about something that's unlimited. That's why we will say here I have unlimited significant figures. Now, with the calculations, how do we add and how do we subtract significant figures? When we add and subtract significant figures, the answer, we add them and subtract them normally, as we do in math. But the answer that we write should have the least amount of numbers after the decimal. What I mean by this? Here I have 2 numbers after the decimal. Here I have only 1 number, so the answer should have 1 number after the decimal. So when I calculated, I got 613.93. So the answer should not be 93 because one of them has only 1. So it should be 613.9. Okay, when you convert it like this, it's not important how many significant figures. You can write it without conversion. Or if you wish, here I have 4 significants and here I have 4 significants, so it's fine. But how many numbers after the decimal? It's not important, just the total amount of significant figures. Okay, now for the multiplication and the division, how do we calculate? We multiply and divide normally as in math, but the answer should have the least total significant figures. Least total, not after the decimal, total. So here I have in total 3 and here I have in total 4. So when I multiply, the answer should have 3 only. So when I multiplied, I got 49.456. So the answer should not be 456, it should be 45. It should be only 3 numbers, so it should be 49.5. Why 5? Because as you see here, I have here 5 and before the 5, 6, so the 5 can give the 4. Even if you write it 49.4, it's okay. Okay, how many significant figures I have as a total answer? I have 3, so when I write the scientific notation, it should have 3 as well. Here, finally, when I multiply these 2 numbers, here I have only 1 significant figure because I say the ones on the left, they are uncountable, and I have here 3, so the answer should have only 1. So when I calculated, I got this number. How to convert this one to be only 1? Now I have here 0.009. Should I write 0.009? No. Why? Because the 9, before the 9, I have 7. The 7 can give the 9 1, rounding in math. So the 9 will be 10 instead of 9. So I will not write it as 10. I will write it as, it's gonna be like this, 0.010, right? 10. But here I have 2 significants, so how I'll write it as 0.01 only, to have only 1 significant figure. And even if I transfer it to scientific notation, it should have only one significant figure. Now, miss, in general, you know that in chemistry, in science, we use calculators. We don't calculate by our hands, but for later on, especially in physics, when you calculate, you should write the answer with the correct amount of significant figures because we are not studying math. So for example, if I told